Hello, this is Lino Tadros, and in this video, this is the third and last piece of lab number 3. And the whole idea here behind this video is what I did in the previous video, creating an Azure function and manually actually adding the 1536 different floats into the vector in Cosmos DB. Now I would like to integrate what I've done before, but I would like to put it part of the Python StreamLit application in the user interface to show you how to do that as well. So let's go ahead and get started. All right, let's head over to Visual Studio Code again. I need to be inside of this Contoso Suite dashboard, the Python app for the StreamLit. So let me go ahead and change this. So we'll say cd source, and I'm going to go into the dashboard. There you go, I'm in the right place. If you remember in a previous video, we added 3 different .NET user secrets, and that went locally on my machine in here as well. Now I need to add 4 more user secrets into the .NET user secrets itself. The first one is the connection string to the Cosmos DB. So let me bring in the line in here. Hopefully you'll still have in your notepad the value of the Cosmos DB connection string. So I'm going to say .NET user secrets set, and then I'm going to be copying and pasting the Cosmos DB connection string, and that is the value of it that I had it before. So we'll push that. Now I know that, oh, I've got an error. Let me see what I did wrong here. Oh yeah, the Contoso Suite dashboard is the Python app. The .NET app is the API app, so we will need to go ahead and do that in the correct place. All right, let me go ahead and get out of this folder, and I need to get into the Contoso, this one, the Web API one. That's the C# based one that has a .NET application, not the Python one. Sounds good. Let me clear this up, and I'm going to go ahead and do another paste in here for the .NET user secret. We will set the Cosmos DB connection string. Let's push enter, and hopefully now it will find the CS proj file for the project, and we'll be able to add it with no problem. 3 more that I need to do. Let me bring in the second one, and that's the .NET user secret set, and that's for the database, and we know that we called it Contoso Suite. Let me push enter on that, and that should be successful as well. Let's do the third one. The third one will be .NET user secrets, and that's for the maintenance request container name, and we called it maintenance request, if you remember, as a container inside of Cosmos DB itself. We'll push enter there. And the final one, that will be probably the embedding model. So let me bring it in, .NET user secret set, and that will be the OpenAI embedding deployment model. And we are using text embedding ADA 002 for this one. Let's push enter there. And now all 4 of them have been added. Plus I have, of course, the 3 from before. So we will have about 7 already available on my machine only. It is not anywhere in this project. So I can safely check all the stuff into GitHub if I want to as well. All right, and now I would like to actually test the vectorization. So that's one of the routes, of course, inside of the Contoso Suite Web API. You will notice if I go to the program.cs, we've seen this before. We have like the /hotels and /bookings and all of these things. And then we used in the previous lab the /chat as well with the semantic kernel. But notice there is one here called /vectorize. And the only thing it does, it actually takes whatever parameter being passed to it, and it actually embeds it into a 1536 different floats. So that's the only thing it does. It just does the embedding by itself. So we can actually try it out, believe it or not, to see how it works. So let me go down in here. Let me clear it up. We'll say CLS to clean this up. And I'm going to say .NET run. I have to have locally, at least on my machine for right now, having the whole API application in C# running on my machine. And once it tells me it's ready to go, I can open up a browser on localhost 5292, and let's go ahead and try this vectorize outside of the user interface. I'm still not using the user interface written in Python for the dashboard. I just want to see if it will do a pretty good job with the embedding. All right, so I'm going to go into my browser. I'm going to say localhost 5292. It will come back with the /, which is great. That is the what I'm expecting. But this time I would like to say /swagger. All right, remember in the program.cs we did enable swagger so that I can actually hit that and being able to see the index from swagger telling me about all the entry points for all the routes, from the getters, from the /hotels, from the bookings, everything. I am interested in this getter for the vectorize itself. Let me go ahead and bring this down, and I'm going to say try it out in Swagger. Alrighty. So I can actually pass the text string here as a parameter, and we'll see if it will come back. My expectation, no matter what I put in here, the query or the question itself has to be embedded. That means the question has to be transformed into 1536 different floats as well. It's not only the vectorization of the data, but also your question has to be embedded as well. All right, let me come back in here and give it a meaningful question. Maybe I'm going to say something like rooms where the air conditioning is not working. Alrighty, so when I actually do that, and I'm going to go ahead and try this out. Go ahead and find the execute. Let's do that, and we'll give it a few seconds. And there it is. It is a 200 OK. It was correct, and it gives you an example in the curl that you will need to do to run it in your PowerShell, for instance. But notice that the response contains an array. It starts with a open bracket. That's an array of 1536. I can actually copy all of that stuff. So let me try to come in here and say copy this guy, or you can copy manually is fine as well. But the idea here is that I'd like to do that, and I'd like to insert it manually for right now into the SQL Server database. So let's go ahead and do that as well. So I'm going to head over to my portal for Azure. I'm going to go to my resource group. Let's see where Cosmos DB is. There it is. And I'm going to go to the Data Explorer like we've done before. I'm going to go to the maintenance request items, and I should have about 50 different items, the 48 that came from the file and 2 that I entered manually. And at this time, I would like to actually start entering a new query. And the button for new queries is right there. Make sure you are on items. And this button here says new SQL query. Let's click on that. And in the query itself, we will enter the following. We go ahead, Control V. I'm going to say select hotel details vector distance, and that will take the request vector, and then there will be a placeholder in here to copy and paste, or actually to paste the 1536 that I just did in the previous one. So I want as a similarity score from the table that I'm actually in here, or from the items itself. Alrighty, so the only thing is this piece in here, and this line of code, of course, the SQL query is available in your lab as well. You can copy and paste it from there, as long as you understand what we're trying to do in here. All right, so this is manual labor. I'm hoping by the time we get to the user interface, all the stuff will be done automatically for you behind the scene in the code. But if you would like to try it out, I need to replace this query vector with my 1536 array, including the brackets and the opening and closing of the brackets as well. So let's go ahead and do that as well. All right, so I went and copied again the 1536 from my question, and I'm going to actually highlight this line. And we'll delete it, and then I want to put the array right there. Alrighty, and I know it looks huge here on the side, but just remember the entire array, including the closing and opening of the array in here with the bracket, has to take place, otherwise this would not work. Alright, let's go ahead and execute this query. And once you execute this query, notice the similarity coming from the items in the database itself, or from the container. There would be a hotel here, the ocean view. Remember, these are the things that I asked for: hotel details and similarity score. This is about 84-85% accuracy. This one is about 86-87%. So you can actually take a look about all the different ones that has to do with an air condition or something like that. So there is a lot of different things in the items that might be very low or very high. You get to specify which one do you want to come back based on the score. Maybe anything below 80% I do not want to see. You can actually change that as well. But obviously it worked. It was able to take your question, embed it into the dimensions that I specified, and then when you make a query using that array for the question. This is the question. This is not the database where it contains the 50 items, but it automatically made a similarity search, and being able to find out with the similarity score on every single item, all 50 of them inside of here as well. Hopefully that makes sense. And you can understand how to do this manually if you want. Of course, we don't want to do this manually. We don't want to create every question, go embed it ourselves, and then insert it into a query. That would be too much work. That's not how it works. But at least you know now what's going on behind the scene. We want to automate all the stuff maybe in a user interface with code to do it automatically for us. So let's go ahead and implement that. I'm going to head over back to Visual Studio Code, and we're going to stay in the Contoso Suite Web API. This is where all the changes will need to take place. So the code is already, almost all of it is there already. You just need to uncomment it so you can understand what's happening. So when you clone this from the forked repository, you don't have to do much other than understanding the code. If I open up the services folder, This time I would like to go to the vectorization service interface, so the I vectorization service. Let's open this guy up and let's take a look. Notice exercise 3 task 3 to do number 1, uncomment the following. So right now we only have the get embedding, and we used that already, if you remember, when we called the /vectorize, just because I wanted to get the dimensions 1536 for my question. But now, if I uncomment this one, I'm adding a new execute vector search that takes all the 1536 different flows array for the vector, and I get to specify the maximum result. Maybe I want only the first 3, first 4, 5. And then there will be a double, which is the minimum similarity score. That means I want anything with 80% or higher. See, we didn't have that before. When I did this in the SQL Server, it went through all 50 and it gave me a score. Some of them went down all the way to 72%, and maybe I don't want those. So this is how you're going to create a very powerful function that will have to be implemented, of course, in the vectorization service.cs. But this is the interface function that will have to return a vector search result. Takes the 1536 floats, it sets the number of results coming back, because sometimes if you don't pass this and you say I want the similarity of 80%, what if you have 1,000 different things that are over 80%? I don't want to return back all 1,000. Maybe I would like to set the maximum to 10 or 20 or something like that. So again, this is very, very important as well. Okay, great. Now that I've added this functionality into the interface, let's go ahead and implement it. We click on vectorization service, and you will notice in here, there is my vectorization class, which has all the information, including the OpenAI client and the Cosmos client, which will end up changing that as well in future labs as well inside of this series of videos. There is my get embedding, which was great. That's the one that actually executed my transformation for the vector. And then we get the exercise 3.2. So you just need to uncomment all of that stuff. This is the execute vector search that I just declared. So I'm going to go ahead and highlight all of this code. There is a lot of it in here, but it will not be that big of a deal. We'll say right click and we'll say go ahead. Where did it go? Edit. Yeah, there you go. Edit and toggle line comment. All right, good enough for me. All righty, so there is the execute vector search. Notice in here we will get the Cosmos client get database from the value we put actually inside of our .NET user secret. We have the container, and then we would create a vector search in here to join the vector select in here based on invariant culture to array. This is based on the culture of the questions, how it was asked in English or whatever. That's why we have to have system to globalization turned on automatically in your code in here. And then we will have the query like we did before, all right? But I'm going to be replacing, of course, the vector distance and the vector string, which contains the array of the floats of the 1500 automatically as well, all righty? So the code here hopefully is not that difficult to understand. The main thing is whatever I did manually, using the /vectorize like I showed you in Swagger, I just need to write this function to do it for me automatically based on every single item. And when I call it, I will tell it how many I need to get back, 5, 6, 10, whatever, and also the distance, the similarity distance in percentage score, 80%, 90%, whatever you decide, that will be passed in here as well. Excellent. My job is done, except one thing, of course, is in my route for the program.cs for the /vector search. Let me go back. Yeah, there you go. There is the /vector search. Notice the exercise 3 in here. We left it so that not implemented exception will be thrown. So I need to replace this guy. Let me go ahead and bring in the correct 2 lines of code. Let me indent this as well. There you go. Oops, nope. Let me go back, make it cleaner. Okay, so in this one we'll say the var results. I'm going to be calling the vectorization services available in my services folder, execute the vector search, and I'll be passing the array of all the floats and the maximum results that will be passed to it, and the minimum similarity score in percentage in here as well. And then I'll return the results. So now I can actually save all the stuff. We'll say Control S, and then we'll do this on this one as well. Let me see if there is something else. Yep, this one. So now there are no numbers next to my file, so that means everything is good to go. The only thing left for me right now, folks, is to hopefully Control C here at the bottom, and we'll say CLS, and I would like to go ahead and do a .NET run. All right, oops, not in one word. .NET run, that will compile it, hopefully with the new code. And when it comes back, it will be ready for me to test it if I would like. There you go, localhost 5292 is ready now. All right, now let's go back to Swagger again, because now it's running, and I can give it another try and see if this will work well. Let me go back in here. I am gonna go to try it out. We'll say rooms where the air condition is not working. I already executed that. So I'm gonna need to actually come back to this area as well. But let me show you what I'm gonna do. I'm gonna go ahead and duplicate this page so I can keep it because I wanna copy and paste from it. And then I'm gonna go to the vector search. Say, not the vectorize, but the vector search. We'll open this up and I'm gonna say try it out. But this one takes multiple parameter that needs to be passed in, the maximum result, and of course the minimum similarity score, plus I need in the body to include the 1536 different floats that I got from my previous question on the /vectorize. So let's try it out. We'll say try it out. The first one I'm going to enter, just give me the first 5. I don't want more than 5. And for the percentage, maybe what we will do maybe 50%, okay? We'll say 50% in here, or actually we'll have to enter it as a 0.5. And then for the body, let me go back here and I'm going to say copy this guy. That's from my question. And instead of this body, I'm going to go ahead and paste the 1536 here as well. All right, let's go ahead and see if I get 5 results instead of the 50, and only the ones over 50% for the specific questions that I'm asking. We'll say execute, and let's see what happens at this point. And this is actually the curl value that will be passed in here. And if I come in, there you go. There is 1, 2, 3, 4, 5, which is correct. And all of them, like I can say 82%, 84, 84. So maybe this is a little bit too much. Maybe we'd like to make it better. So maybe if I actually make it 85%, let me go back in here just so we can prove the point. We'll say 0.85 and we'll execute one more time. Oh, what did I do? 0.85. Alrighty, and then we'll execute one more time. Much better, okay? So it doesn't like the dot. It has to be a 0 dot. And notice only one, even though I told it to return 5, but actually the similarity percentage, only one was over 85%, which is 86%. So it does not have to return anything. And the thermostat does not appear to be working in room so and so, and the air condition until blah, 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 blah. So the similarity definitely was able to find which one or which 5 have something over 85%, and it works really well. Hopefully you have an idea of how this stuff will work from now on. Now the final piece, I'm going to head over to the code and I'm going to enable actually everything I've done. Instead of doing that in Swagger manually, I would like to turn on the page inside of my Python code for the dashboard to do this automatically for me. All right, let's go ahead and go back to the Contoso Suite dashboard. I'm going to open up pages, and the third page, which is the vector search, is the one responsible for that. So if you come into this code in Python, look for the main function. That is the main function. And then we have some placeholders in here. We have to-do number 4, 5, and 6. We already did the first 3 for exercise 3, but in here in the if query in here, all right, when you submit your query, right now, even if you leave it like this, the code will work, but it will not do the vectorization. So I just need to add some code in here that will allow me to, first of all, vectorize the query text itself. That's your question, okay? And then we will perform the vector search, and then we will need some code as well to display the results. So hopefully that will not be too hard. Let me go ahead and bring in the code to show you one by one how to do that. The first one for the to-do number 4, I'm going to come in here and we will say, and make sure with the indentation as well, please, because Python is very picky, all right? So the query vector is having a handle query vectorization, and we're passing the query as well. So we will have a function, handle query vectorization. You will see it all the way at the top in here, handle query vectorization. That will actually use the secrets that we have available in the API endpoint, and it will request a getter on the /vectorize. So it's exactly what I did in Swagger with the vectorize, but in code as well with a couple of lines of code. It's not a big deal. Hopefully that makes sense. And then the next one will be actually the performance of the query itself. So I'm going to bring in the line, and this line will be vector search results equals handle vector search. And again, this function is available at the top. You can take a look at it, how we did it, handle vector search as well. We're bringing in the endpoint for the API secrets. The headers, it's a JSON application. And then we will do a post. This is not a getter at this point. Passing the /vector search that we've seen in Swagger, And this time we'll have to pass in the 1536 floats for the vector and the parameters for the maximum result, which it was 5 for me during the demo. And then the minimum similarity scores, I'm going to be passing there, whether it's 50% or 85%, passing the headers that contains the application JSON, the timeout in seconds, and to verify is false for right now, and then the return a response. So hopefully that makes sense on exercise the to-do number 4 and 5. And at the end, the easiest part, of course, is to show the results, to display the results to the user in the user interface of the StreamLit Python application. And the way to do that, let me bring it up in here as well, and that will be the ST table vector search results.json, and we will have it available for us this way. All right, I can actually save this file. Again, I'm not going to Azure yet. I would like to do it manually here on my local machine first. Don't touch, of course, the terminal running the API. The API is still needed, so we need to leave it alone. We'll need to go to another instance. Let's go to this one, for instance, and I'm going to say cd source, and we will go into the Contoso dashboard. There we go. And then the line of code that we have been running so many times already is to run the Python like this. We'll say python-m streamlit run index .py. We'll say go for it, and that will start localhost 8501. And let me bring it up to this machine in here, to this monitor. All right. So I'm in pretty good shape. The user interface is running locally and the API is running locally for right now. Let's give it a try. I'm going to go to the third one now. It says vector search. Let's click on that. And you'll notice I can actually come in here for the query. Let me go ahead and enter something like show me rooms where the air condition unit is malfunctioning. How many answers would you like to come back? Well, let's go ahead and enter the maximum amount. Maybe we'll leave it at 0. Will result all results, okay? And then the similarity, remember, between 0 and 100%, you'll have to use it in a decimal like this. So I'm going to actually, let's say, keep it at 80%, okay? And let's go ahead and submit and see if these two parameters, the maximum result and the minimum similarity score, plus my question in here will have to be embedded and included as a vector result coming back into the question itself. So we'll say submit that, and we will see if this will work. All right, these are all the ones that have a problem with the air condition, and you can see in here it did a pretty good job. Let's say, for instance, I want to change this to only 5, alrighty, and maybe I'd like to move it to 85%. How about that? All right, and let's submit and let's see. Oh, there is only 3 that is over 85%. That has to do with malfunctioning of the air conditioning. Anyway, so the user interface did exactly what Swagger did, but we included the code in the Python so that we can use it on the StreamLit application as well. Hopefully this is useful, and you can actually see why this is very valuable to be able to do something like this using all the power of AI available from Azure as well. Thank you so much, and I hope to see you again in the start of the lab number 4. All right, thank you.